Welcome to another episode of Learning. Please like my videos and share them with your friends and colleagues. This is my channel. Please subscribe my channel if you have not already subscribed. Thank you. We continue the discussion of the solutions of the problems that have appeared in the IIT JAM Mathematics 2024 examination. In this video, we discuss the solution of a problem from the section Algebra, and the problem is from the subsection Groups. And it is a multiple select question. There may be more than one answer. And the question number is 33. This question is suitable for all these examinations. In particular, this question is suitable for the aspirants of CSIR NET exam and GATE mathematics exam. The given question is, which of the following statements are true? We are given four options. Option A, the additive group of real numbers is isomorphic to the multiplicative group of positive real numbers. Option B, the multiplicative group of non-zero real numbers is isomorphic to the multiplicative group of non-zero complex numbers. Option C, the additive group of real numbers is isomorphic to the multiplicative group of non-zero complex numbers. Option D, the additive group of real numbers is isomorphic to the additive group of rational numbers. Question looking to be lengthy, and don't feel any fear of it. It is an easy problem. Right. We now discuss the solution of the problem in detail. Let us take the option A. The additive group of real numbers, that means capital R, that set of real numbers R under addition, that group is isomorphic to the multiplicative group of positive real numbers, that is R plus under the multiplication. Solution. At first glance, we get the idea that this option A is true. It's very familiar to us. It is an example what we normally do in our BSc class. It is a worked out example for all our students. Now, define a map. So we have two groups. One is additive group of real numbers, that is R under addition. The other is multiplicative group of positive real numbers, that is R plus, stands for the positive real numbers under multiplication. So phi, define a map, phi from R plus to R under the addition plus to R plus, that is positive real numbers under multiplication, by phi of x is equal to e power x, e to the power of x, for all x belongs to R. Now it's very simple to show that phi is a homomorphism. For all x comma y belongs to R, the domain, we have phi of x plus y is equal to e to the power of x plus y. That is equal to e power x multiplied by e to the power of y. That is equal to phi of x into phi of y. Thus, phi is a homomorphism. We show phi is 1 to 1. Phi of x is equal to phi of y will imply e power x is equal to e power y. Taking the logarithm, natural logarithms on both sides, you will get x is equal to y. So thus phi is a 1 to 1 map. And option 3. No, the third one, phi is on to. For any y belongs to R plus the codomain, there exists an x which is equal to ln of y in the domain R, such that phi of x is equal to e power x is equal to e power ln of y is equal to y. So thus every element of R plus the codomain has a pre-image in the domain R. So this shows phi is on to. Thus phi from R plus to R plus under multiplication is a bijective homomorphism. Thus they are isomorphic. So the option A is true. So right, we take up option B, the multiplicative group of non-zero real numbers, that is non-zero real numbers में R star under multiplication, the group is isomorphic to the multiplicative group of non-zero complex numbers C star under multiplication. Right. We ask the question, the group R star under multiplication, is it isomorphic to the group of non-zero complex numbers under multiplication? We observe that in R star under multiplication, the only elements with finite order are 1 of order 1 and minus 1 is of order 2. There are only 2 elements with finite order. But whereas in C star under multiplication, there are infinitely many elements of finite order. Finite order. For example, omega is of order 3, I is of order 4. These are omega is the cube roots of unity, I is the fourth roots of unity. In general, we can talk about the nth roots of unity for any positive integer n. Right. So that means e to the power of 2 pi I by n is of order n. For example, e to the power of 2 pi I by n has order n for any positive integer n greater than or equal to 2. So thus C star under multiplication has infinitely many elements of finite order, whereas R star under multiplication, the group, has only 2 elements of finite order. So there, since an isomorphism preserves the order of elements, these 2 groups are not isomorphic. Right. So the option B is not true. Right. We move to the next option. Option C, the additive group of real numbers, that is R under addition, the group, is it isomorphic to the multiplicative group of non-zero complex numbers, that is the group C star under multiplication? Is it so? Are they isomorphic? Now, once again, we look at R under addition, the group. The only element of finite order is the additive identity, namely 0. And what happens to the remaining non-zero elements? They are all of infinite order. Every non-zero element is of infinite order in R plus. Now we move to, in C star under multiplication, there are infinitely many elements of finite order, infinitely many, as seen in option B. So, in R plus, there is only one element of finite order. In C star, there are infinitely many elements of finite order. Since an isomorphism preserves the order of elements, these 2 groups are not isomorphic. Therefore, option C is not true. We move on to option D. The additive group of real numbers, that is R under addition, is it isomorphic to the additive group of rational numbers, that is Q under addition? Are they isomorphic? That is the question. Now, if there is an isomorphism, what is an isomorphism? A homomorphism and it should be bijective. When it is bijective, the cardinality of R must be equal to cardinality of Q. Cardinality of R is C, uncountable, and cardinality of Q is LF naught, is different, no? C is greater than LF naught. LF naught is countably infinite. So, if they are isomorphic, then there is a bijection between R to Q. Therefore, the cardinality of R must be equal to the cardinality of Q. That is, the cardinality of R is C, the continuum. The cardinality of Q is LF naught. And C is uncountable, LF naught is countable, and this is not true. C is strictly greater than LF naught. This is not true. Therefore, these two groups cannot be isomorphic. Therefore, option D is not true. Combining all the options, the answer to this question is option A. That is the detailed discussion of the solution of this problem. Right. It's a simple question, but students normally feel, by looking at the question, they feel it is difficult. But it is not. It is an easy question. I am sure that you have understood the solution of this problem. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please join as a member in my channel and support me and my channel. Yes, this is my channel. Please subscribe my channel if you have not already subscribed. Yes, I will certainly meet all of you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.